Here's a statistic that should keep every software engineer awake at night. 80% of AI code bases today are just plumbing. That's right, 80%. Not artificial intelligence, not machine learning algorithms, not breakthrough innovations. Just abstraction layers, error handling, retry logic, and configuration management to make different libraries work together. Only 20%, a measly 20%, is actual AI functionality. Think about that for a moment. We're in the middle of the greatest technological revolution since the internet, and 4/5 of our code is just glue. Welcome to Mindcast, the podcast where we dive deep into the ideas shaping our technological future. I'm Will, and today we're exploring something that's going to fundamentally reshape how we think about software engineering itself. We're entering what I call the post-syntax era, a time when the very foundation of programming is shifting beneath our feet. And at the center of this revolution, Agentic AI, not generative AI. That's yesterday's story. I'm talking about autonomous agents that can reason, plan, and execute complex workflows without human babysitting. By the end of today's episode, you'll understand how these agents are making human-readable code obsolete, why the libraries we depend on are becoming liabilities, and what this means for the future of how we build software. Trust me, this isn't just another tech trend. This is the most significant paradigm shift in programming since we moved from punch cards to keyboards. So let's dive in. First, let's get our terminology straight, because this distinction is absolutely crucial. When most people hear AI in software development, they think of ChatGPT helping them write functions, or GitHub Copilot suggesting code completions. That's generative AI, and it's reactive. It responds to prompts. It's like having a very sophisticated search engine that can write code instead of finding web pages. But agentic AI? That's a completely different beast. Think of the difference between a calculator and a research scientist. A calculator waits for you to input numbers and tells you the result. But a research scientist, they maintain long-term goals, design experiments, analyze data, pivot when something doesn't work, and persist until they solve the problem. That's what agentic AI does with code. You don't give it a prompt like write me a function to query this database. Instead, you give it a mission. Optimize this database for read latency. And then it goes to work, autonomously. It analyzes query logs, proposes indexing strategies, writes migration scripts, tests them in a staging environment, monitors performance, and deploys the changes, all while handling errors and backtracking when something fails. This shift from human in the loop to human on the loop, or even human out of the loop, changes everything about what we need from programming languages. Now, here's where it gets really interesting. For decades, we've optimized programming languages for human brains. Python became popular because it reads like pseudocode. JavaScript spread because it's forgiving with types. We've built massive ecosystems of libraries. Pandas for data analysis, requests for HTTP calls, React for user interfaces, all designed around the principle of don't repeat yourself. But here's the problem. Agents don't think like humans. They don't get fatigued by repetitive code. They don't need tutorials or Stack Overflow answers. They process tokens, not tutorials. And they prioritize semantic precision over syntactic sugar. Remember that 80% plumbing problem I mentioned? Here's what's happening. When you want to support multiple AI providers, OpenAI, Anthropic, Google, you end up maintaining parallel code bases disguised as one. You're constantly dealing with different API formats, retry mechanisms, error handling patterns. It's dependency hell on steroids. For an agent, this is pure waste. An agent doesn't need a massive library capable of handling every edge case in the HTTP protocol just to make a single GET request. Instead, it can generate a specific ephemeral function optimized for that exact request, execute it, get the result, and then discard the code. This is what I call ephemeral software, code that materializes when needed and dissolves when its purpose is served. It's like having a blacksmith who forges a custom tool for each specific job, rather than maintaining a warehouse of generic tools that mostly don't fit quite right. But this transition to agent-generated code brings with it a terrifying new class of security vulnerabilities. I call them hallucinated packages. Here's how it works. AI agents trained on vast amounts of open-source code often hallucinate the existence of software packages that should exist but don't. For example, an agent might assume that because there's a Google Search API package, there must logically be a Google Search API v2 package. So it writes code attempting to import it. Now here's the scary part. Malicious actors have figured this out. They identify common package names that AI models hallucinate, register them on repositories like PyPI or NPM, and fill them with malware. It's called slop squatting. When an agent, or a human relying on an agent's code, attempts to run the script, it downloads the malware. This isn't theoretical, it's happening right now. Security researchers have documented dozens of these poison packages already sitting in public repositories, just waiting for agents to stumble into them. This reinforces why we need ephemeral software running in strictly isolated environments, sandboxed containers where a compromised package can't access sensitive data. But more fundamentally, it suggests that agents may eventually stop trusting public repositories altogether, preferring to generate their own implementations rather than risk importing a poison dependency. Think about what this means. The entire concept of open-source package management, built over decades, might become obsolete in an agent-driven world. This brings us to our third major insight. We're moving beyond syntax entirely, and I mean that quite literally. The current trend of what I call vibe coding, where developers guide AI through high-level intents and feedback, essentially coding by feel, is just a transitional phase. Vibes don't guarantee correctness. An autonomous agent managing a bank's ledger can't rely on code that feels right. It needs code that is provably correct. Enter formal verification languages like Daphne and Lean. These aren't just programming languages, they're mathematical proof systems. When you write code in Daphne, you're not just telling the computer what to do, you're providing a mathematical proof that your code will behave correctly under all possible conditions. Now here's the fascinating part. While formal verification has been notoriously difficult for human developers, AI agents are proving surprisingly adept at it. Recent experiments show that large language models can generate formally verified code, complete with mathematical proofs, with remarkable accuracy. Picture this workflow. An agent writes code in Daphne, along with the formal proof that it's correct. A theorem prover validates the proof. If it passes, the system compiles the code into high-performance machine code for execution. The agent provides the creativity, the formal verifier acts as a guardrail against hallucination. But we're going even further. Researchers are exploring proof-carrying code, where executable programs come bundled with cryptographic certificates proving their safety. The host system doesn't need to trust the agent, it only needs to trust the mathematics. And ultimately, we might abandon human-readable syntax altogether. Think about it. Current programming involves a lossy translation process. Human thought becomes code, which becomes tokens, which become latent space representations where the actual thinking happens. Researchers are now exploring latent space programming, generating programs directly in the high-dimensional mathematical spaces where AI operates, skipping the text phase entirely. It's like, imagine if musicians could compose directly in sound waves rather than having to write musical notation first. We're moving toward what I call a universal intermediate representation for intelligence. Just as compilers use intermediate representations to optimize code, AI systems might use a standardized machine-native format
that's denser and less ambiguous than English or Python. In this future, a function might not be a text file containing code, but a specific vector that, when injected into a model, triggers a specific behavior. If Agent A learns a new way to process data, it doesn't write a tutorial. It transmits the learned embedding weights to Agent B, instantly upgrading its capabilities. We're talking about a world where intelligence itself becomes transferable, like copy-pasting skills between minds.
So what does all this mean for the future? Let me give you 3 concrete implications that I think will reshape not just how we write software, but how the entire industry operates. First, developers are becoming system architects. If agents are writing the implementation code, what do humans do? We move up the abstraction ladder. Instead of writing Python functions, we'll be designing the constitutions of AI agents, defining their goals, constraints, and available tools using control languages like DSPy and SGLang. We're shifting from writing logic to architecting minds. Think of it like the evolution from electrical engineers hand-wiring circuits to hardware designers using HDL languages. The fundamental work moved from physical implementation to logical design. That's happening to software development right now. Second, the economics are shifting from subscriptions to micropayments. When agents can autonomously discover and utilize tools, we need a new economic model. Enter the X402 protocol, referencing that old HTTP 402 payment required status code that was reserved in the 90s but never used. Here's how it works. An API responds to a request with a 402 code, includes a crypto address and a price, say 0.0001 USDC. The calling agent instantly pays the fee and receives the resource. This creates a meritocracy of code, where developers can publish high-performance algorithms as microservices and get paid every time an agent finds them useful. We're moving from software as a service to what I call function as a resource. Billions of tiny autonomous transactions creating a thriving economy of specialized agent capabilities. And third, we're witnessing the death of developer evangelism and the rise of agent SEO. For decades, the success of programming languages and libraries depended on winning the hearts and minds of human developers. Companies hired charismatic advocates to speak at conferences and build communities. But agents don't care about cool logos or friendly Discord servers. They care about token efficiency. Can I read the documentation in fewer tokens? They care about ambiguity reduction. Is the API behavior deterministic and strictly typed? And they care about discoverability. Is the tool indexed in a format I can retrieve? This means marketing to an agent involves optimizing for machine consumption. Documentation needs to be refactored from verbose tutorial-style prose to dense schema-rich formats that agents can ingest without hallucination. We're essentially doing SEO for artificial minds. The implications are staggering. The entire developer relations industry, conferences, tutorials, community building, becomes irrelevant when your primary users are autonomous agents that evaluate tools based on mathematical efficiency rather than human appeal. Think about what this means for open source. The current model relies on corporate charity and premium support, neither of which applies to agents. But if developers publish their algorithms as X402-enabled microservices, they can monetize code utility directly. We might finally solve the open source funding crisis by creating a true marketplace for algorithmic intelligence.
So, let me tie this all together. We're not just seeing incremental improvements in programming tools, we're witnessing the structural reformation of software engineering itself. The post-syntax era will be defined by 4 fundamental shifts. Formalism over readability. Languages like Daphne and Lean will become standard for agent-generated code, ensuring safety through mathematical proof rather than human review. Ephemerality over persistence. Software will be generated just in time for specific tasks and then discarded, eliminating dependency hell and reducing supply chain risks. Control over implementation. Human developers will migrate to higher levels of abstraction using frameworks like DSPy and SGLang to architect agent minds while agents handle the implementation details. And micropayments over subscriptions. The software economy will fragment into billions of autonomous machine-to-machine transactions, creating entirely new business models around algorithmic utility. We're witnessing the end of the rockstar developer who memorizes syntax and debugging tricks. Instead, we're entering the age of the system architect who defines the boundaries of reality for autonomous minds. The future of programming isn't writing code. It's defining the constraints of the latent space in which intelligence operates. And that future? It's not coming someday. It's happening right now, in research labs and startups around the world. The question isn't whether this transformation will occur, but whether we'll be ready for it.
So here's my challenge to you. Start thinking like a system architect today. Instead of focusing on the latest JavaScript framework or Python library, ask yourself, what constraints would I want to define for an autonomous agent? How would I structure the problem space to ensure reliable, verifiable outcomes? If you're a developer, experiment with formal verification tools like Daphne. If you're in leadership, start thinking about how your organization would operate when 80% of your code is generated by agents. If you're an entrepreneur, consider what services agents might pay micro-fees to access. Because here's the thing, this transformation is happening whether we participate or not. The agents are already here, they're getting more capable every month, and they're going to reshape our industry from the ground up. The question is, are you going to be part of designing that future, or are you going to wake up one day and find that the world has moved beyond human-readable code while you were still debugging Python imports? The post-syntax era is beginning. Welcome to the future. Thanks for joining me on Mindcast. I'm Will, and until next time, keep questioning the foundations because they might not be as solid as you think.